Okay, so today we'll solve GATE 2022 question. This is a question from functional analysis. This is question number 42. Okay, so let T be a linear operator which is a map from L2 of minus 1 comma 1 to L2 of minus 1 comma 1. T is defined by T of F is defined by F tilde, which is basically F evaluated at the point minus X. This is almost everywhere. And M denotes the kernel of this operator I minus T. Then the distance between the function phi equals to e to the power t and M is the four options are given. We have to check which one is correct. Okay. So in order to solve this, this is the NPTEL reference. This you can check. Okay, so let's try to solve this one. So what it is given, T is a map from L2 of minus 1 comma 1 to L2 of T of F. How is it defined? At the point X, it is F tilde of X, right? Means F evaluated at the point minus X. So this is the T, and what is M? M is the kernel of this operator I minus T. So means this is how it is defined, all such X such that I minus T of Fx should be 0. So what is this? So if you just write down, so this is means Fx and minus T of Fx. What is T of Fx? T of Fx is, so this is F of minus X, because T of Fx is F of minus X. This is 0. So which is same as all such X such that F of X equals to F of minus X. Right, for all F here. For all F in this L2 of minus 1 comma 1. Sorry, this is for all F here. For all X. So means what is this? So this is basically collection of all even functions, right? Because F of X equals to F of minus X means collection of, this is the collection of all even functions in L2 of minus 1 comma 1. Right, and this is because this is a kernel of I minus 2, so this is a closed linear, closed subspace, right? And note that L2 of minus 1 comma 1, this is a Hilbert space. Note L2 of minus 1 comma 1 is a Hilbert space. And M is a closed subspace of the Hilbert space L2 of minus 1 comma 1, right? So in a Hilbert space, every closed subspace has a orthogonal complement. So therefore you can write L2 of this minus 1 comma 1, you can write M direct sum M perp. So we know what is M. We know M is basically collection of all even functions. Now what is M perp? That that we have to check. So claim that mperf is the collection of all odd functions. Claim mperf is the collection of all odd functions. In L2 of minus 1 comma 1. So how to prove this one? So and note that in this, what is the inner product basically? Here, how the inner product is defined, f and g. This is basically minus 1 to 1 fx. So here it is a basically assume that this is a real inner product space. So gx dx. So this is the inner product here. So this direction. So we will prove that mperf basically collection of all odd functions. So suppose, so we will basically prove that if f is an odd function, then it is belongs to the mperf. Means as m is a collection of even functions, so if we take the inner product with functions with one function from m and one function from mperf, then because the inner product should be 0. So let f be a odd function. And let g be a even function. And also assume and let g belongs to m. Implies g is an even function, right? G is an even function. So f dot g is an odd function. So therefore integration minus 1 to 1. So basically this inner product f inner product g is integration minus 1 to 1 fx gx dx, and as f times g is odd function, so this integral is 0. So f inner product g is 0 implies f is in mperf, because this is true for all g in m, right? So therefore if it is an f is an odd function, then it belongs to an mperf. So this is the forward direction, suppose, and converse direction we have to prove that if suppose any function which is orthogonal to all the functions, all the even functions, then it should be odd functions. So let if g be m, let if g is orthogonal to every even function, then what will happen? Then we have to show that g should be odd, right? So basically we have to show that, then we have to show g is odd function. So let's compute this integral minus 1 to 1 g of t plus g of minus t with ft. and where let f is in M, so means f is an even function dt, then what will happen? So this is minus 1 to 1 ft gt dt plus here minus 1 to 1. Now make a change of variable here. So this is what is, let me write it, then we'll. Okay, so now, so this I have just written out. Now what we will do, just in the second integral make change of variable. So ft gt dt plus, if you make change of variable t goes to minus t, what you will get? You will get f of minus t g of t dt, and as f is in M, so it is an even function, so basically f of minus t is again ft, so you will get basically 2 times minus 1 to 1 ft gt dt, and as g is orthogonal to every even functions, so means this integral is become 0, and so this is true for all f. In M, so which implies, so therefore g of t plus g of minus t equals to 0 almost everywhere, so which implies g is an odd function. So here we assume g is orthogonal to every even function, means we have assumed that g is in M per, we have shown that g is an odd function, so therefore we have got M per is the collection of odd functions. So we have denoted L2 of in terms of M perp, so this is a collection of even function and this is odd function, and note that this direct sum means in their intersection is only 0 functions is there, right? So 0 functions, and also note okay, so now we have to find the, so what is the question, that we have to find the distance between. Now come back to the what we have to find. We have to find distance between u to the power t and M. Now here we will use one result. So in order to find the distance between a point and the subspace, so this is the standard result from functional analysis. So let M be closed linear subspace of Hilbert space H, then for each x in H there exists unique point x naught in H such that x minus x naught, which is the distance between, is the means norm of x minus x naught is basically distance of x to that subspace H M, and this distance is basically defined infimum of all such x norm of x minus y or y in M. So basically, if M is a closed linear subspace, then for any point x in H, there exists a unique point x naught, so that norm of x means there is a closest point which is the x naught, so that distance between x and M is given by norm of x minus x naught. And this x naught is basically called the projection of x onto M. And this is because this is a unique, so this is well defined. This x naught is called the projection of x onto M. So this will denote P of M of x is x naught. Right, basically note, we can write any x as x naught plus x minus x naught, and one can show that this x naught as in M, and this belongs to an M path. And so this is the direct sum decomposition, because you can write it in a unique way. Okay, so this is the, so in order to finding distance, we have to finding the projection of x onto M, right? So here we have to find the distance between area ET and M. So you have to find the projection of ET onto M. So how to find this x naught, where basically projection of ET onto M? So this we will basically find by this decomposition. So what we have got, note, here we know L2 of minus 1 comma 1 as M direct sum M perp, where M is the even function, collection of even function, M perp is the collection of odd function. As any fx, you can always write fx plus f of minus x by 2 plus fx plus minus f of minus x by 2, where this is even function and this is odd, as this and this is unique, this is unique. So what is basically this projection, right? So what will be the projection of f into M in the collection of even function? So Pm of fx is basically fx plus f of minus x by 2, right? So this is the projection. So therefore this is the means this, so therefore for e to the power t, projection will be here, projection of M of e to the power t will be e to the power t plus e to the power minus t by 2. So therefore distance between e to the power t and M, so this is by the theorem is given by the norm of e to the power t minus Pm of e to the power t, right? So this is the x naught there, and what is this? E to the power t minus e to the power t plus e to the power minus t by 2. So basically this is e to the power t minus e to the power minus t by 2, And what is this norm? If you write down the definition, this is minus 1 to 1 e to the power t minus e to the power minus t by 2 whole square dt half. So if you simplify this, minus 1 to 1 e to the power 2t minus 2 plus e to the power minus t dt. If you integrate it out, what you will get? Basically this. I'm just writing what you will get. Square minus e to the power minus 2 minus 4. So this is the distance between e to the power t and m, right? So let's check which option is correct then. So therefore option number D is the correct option. Okay.